Welcome, students. This is our day 2 for solving systems of equations. We're going to learn a second method today, which is called elimination. Elimination means to get rid of something, and so our goal in an equation, let's say if we have 2x plus 3y equals 6 and 5x plus 4y equals 13, our goal is going to be to get rid of one of the letters completely so that we are only left with a single letter in the problem. And once we get down to a single letter, we'll have something like 2x plus 3 equals 6, and we know how to solve these with just one letter in them. Once we get done with that, we will have to do a little bit of the substitution stuff from last class period, but it'll be a lot faster. This is a much quicker process than the substitution. So if you didn't like how long the substitution stuff took, this will be easier for you. Okay. Here's a quick look back at what substitution looked like. You had to have one of the equations solved. So this one was solved, and what we do is we took and we plugged that in for here. And so when we did that, we got 2x plus 1 equals negative x minus 2. That was our first substitution that we did. And remember, this is just a review. We're just looking back at the steps for how we did that. We plus 1x to both sides. That becomes 3x plus 1 equals, that cancels out, negative 2. Box our 3x, minus 1 to both sides. 3x equals, that cancels out, negative 3. When it's beside it, we divide it. And so we find out that x equals negative 1. And remember, that was half our answer. Then we took that back and plugged it in anywhere we wanted up in those top two equations. Y equals, instead of 2x, it's 2 times negative 1 plus 1. Then we do this. 2 times negative 1 is negative 2 plus 1. And negative 2 plus 1 is negative 1. And so this is our answer. And so that was the work required for doing substitution. Elimination is going to be faster. We're not going to do this second problem because it'll just take too long in the video. So we're going to switch over to our elimination. To use this method, you add the equations together. The goal is to eliminate one of the variables, either x or y, it doesn't matter, so that you can be solved for the other variables. Our goal is to look for coefficients that will automatically be eliminated when the equations are combined. Things that would automatically eliminate each other would be like 2x and negative 2x. These are called opposites. So you're going to be looking for opposites. Okay? After you find the value of one of the variables, you will have to substitute it back in, so the very end of it will look similar to what we learned last class period. Here's a couple examples that do that. Okay. When we look at this first set of examples here, we look at 2x and 3x, and this first column right here, these will not eliminate each other. But when you look to the y's, if we add straight down right here, 2x plus a negative 2x, these will cancel out. And so that's what we're going to do. I usually put a plus sign right here on the side. 2x plus 3x is 5x. 2y minus 2y cancels out. Negative 2 plus 12 is 10. When it's beside it, I divide it, so divide both sides by 5, and I get x equals 2, and that's my first answer. So see how fast that was to get the first answer? Now the second answer does require a little bit more work, because you do have to go back to substitution. So we're going to take this and we're going to put it right there. So 2 instead of x is 2 times 2, plus 2y equals negative 2. So we distribute there, that's 4, plus 2y equals negative 2. Draw my line down, box my 2y, minus 4, minus 4. 2y, negative 2 and negative 4 is negative 6. Divide both sides by 2. And y is negative 3. And that is my second answer, and that's my total solution. So it is considerably less work, especially right there to find that first answer. And look at number 4. 4x and negative 4x, those are going to cancel when I add straight down, so that's what's going to eliminate. So I'm going to go ahead and put a plus sign there. 4x minus 4x cancels out. Negative 2y plus 4y is 2y, and 14 plus a negative 2 is 12. When it's beside it, I divide it, and I get y equals 6. So that fast, I have my y answer. Now I'm going to take that and plug it back into either one. It doesn't really matter. I'm going to plug it into the top one up there. So that'll be 4x minus 2 times, not y, but 6 equals 14. Distribute that. That's 4x. Negative 2 times 6 is negative 12 equals 14. Draw my line. Box plus 12 plus 12. Those cancel. 4x equals 14 plus 12 is 26. Divide both sides by 4. And x equals 26 divided by 4. That goes in there 6 times. 6 times 4 is 24. With a remainder of 2, so that's 1/2. So that is 6.5. Not all systems of equations have coefficients that eliminate easily. Therefore, we must have other methods to solve them. We can use what's a multiplication method, where we choose a variable and we were able to multiply either the top or the bottom one by any number we want to cause elimination. So when I look at number 5 here, in this first column right here, 3x and x will not eliminate. When I look in this column, 2y and negative 5 will not eliminate. So what I do then is I look at, could I make this 3 up here into a negative 1 so it would cancel with the 1x below, or could I make this 1x underneath a negative 3? And it is true that I could make this a negative 3 by multiplying a whole equation by negative 3. So on top, I'm just going to leave that one alone. That'll be 3x plus 2y equals 0. But I'm going to triple rainbow that. So that becomes negative 3x. Negative 3 times negative 5y is positive 15y. And negative 3 times 17 is negative 51. Now I draw my line. These will cancel, so I'm going to go ahead and add straight down. 3x minus 3x cancels out. 2 plus 15 is 17y. 0 plus a negative 51 is a negative 51. When it's beside it, I divide it, so I divide both sides by 17. And oops, I wrote 15. I'll need my eraser. Negative 51 divided by 17 is a negative 3. So that's my y answer. I can take it back and plug it into any of the top 2 equations that I want. I'm going to put it right there. So that will be 3x plus 2, take out the y and put negative 3, equals 0. So distribute that there. 3x, 2 times negative 3 is negative 6, equals 0. Plus 6 to both sides. 3x equals 6. I'll bring that up here. 3x equals 6. When it's beside it, I divide both sides, and x equals 2. So my answer for this one up here is x of 2 and a y of negative 3. Alright, our second problem over here, number 6, we look at 2x and x in the first column, and can we make a 2x into a 1x, or can we make a 1x into a 2x, and we actually need one of them to be negative. You can also look at the 3y and the 2y, but it's much easier to change this bottom one to be a negative 2 by multiplying everything in there by negative 2. And so again, it's going to be a triple rainbow. Okay? So the top one will stay the same, 2x plus 3y equals 6. This one will change to be negative 2x, then negative 4y, and negative 10. We draw our line down. Those are going to add straight down. Those cancel. 3 plus a negative 4y is a negative 1y. 6 plus a negative 10 is negative 4. When it's beside it, we divide it. And pretty quickly we're able to get that y is 4. And then we're going to plug it back in. I'm going to put it right there. So x plus 2 times 4 equals 5. So I took out that y and I put in that 4. Distribute there. That's x plus 8 equals 5. Subtract 8 from both sides, and x equals 5 minus 8 is negative 3. And so our answer is negative 3, positive 4. Alright. The last set of problems here, number 7, is one of the more complicated ones, because you're going to have to multiply both equations by something to get it to eliminate. You can't make a 3 into a 2 or a 2 into a 3 very easily, but I could make them both into 6s by multiplying by each other. So I'm going to multiply the top one by 2 to make that into a 6, and I'm going to multiply the bottom one by not just 3, because I want it to be the opposite, I'm going to do negative 3. So I'll have a triple rainbow up here. That'll make 6x plus 4y equals 18. And then I'll have a triple rainbow on the bottom one, which will make negative 6x. There's my elimination. Negative 15y and negative 51. Draw my line. Add straight down. Those cancel. 4 plus a negative 15 is negative 11y. 18 minus 51, or 18 plus a negative 51, is a negative 33. When it's beside it, I divide both sides by negative 11, and I get that y is 3. I take that and plug it back in to either of the equations. I'm going to do the top one. So that's 3x plus 2y equals 9. And I'm going to take out the y and put 3 in its place. So that'll be 3x plus 6 equals 9. Minus 6 from both sides. 3x equals 3. When it's beside it, I divide it, and so x equals 1. So x is 1, y is 3. Okay. Number 8 and 9 have asterisks beside them for a reason. Those are the special cases like we talked about the other day. One of them is going to be a situation where there are no solutions, and one of them is going to be a situation where it's infinite solutions. And so we'll see which one happens. Okay. On this first one up here, we have elimination that's going to occur pretty quickly right there. Those eliminate, and I'm left with nothing on the left-hand side. 12 plus 8 is 20. Then you have to decide, is this true or false? And it's obviously a false statement. And if you'll remember from our lesson on substitution, false statement means no solution. It means nothing will work. So a false statement makes them parallel lines. Similar thing's going to happen on this one over here. The 2x's cancel out. The 3y's cancel out, leaving us with 0. 12 minus 12 is 0. This is a true statement. And true statement means infinite solutions. Okay. Hopefully you found this to be a little bit easier than the substitution. We're working towards easier ways of doing this than before. So hopefully this will work out better for us.